Okay, so just a quick introduction to exponentials and logarithmic functions. And I'm going to start by just talking about a couple of old familiar functions that will hopefully help you make the connection with exponentials and logarithmic. Okay. So the first one I'm looking at is f of x equal to x squared, a very old familiar function to us. It did not take you long to figure out how to use this function and see something like, let's say 3 squared equals 9, 10 squared equals 100, and so on. But at some point we wanted to say, okay, how do I go backwards? How do I take the 9 and go back to 3, or the 100 and go back to 10? Okay. Well, then we introduced this idea of the square root function. Okay. We had no notation for it at this point. Okay, so we just created this symbol, and that meant the square root of the number. Okay. Now again, when we started working with this, the only reason we were able to figure out the square root of 9 is because we knew 3 squared was 9. So then going backwards, the square root of 9 is 3. Okay. Similarly, the only reason we know the square root of 100 is because we know 10 squared is 100. So when we come over here, the square root of 100 is 10. Okay. Now you've worked with square roots long enough. You don't think about this every single time. You don't go back and forth. All right. You're familiar with square roots. You know square root of 9 is 3 and so on. Okay. Another root we don't work with quite as often is cube roots. But again, this comes from the fact that we have f of x equal to x cubed. Okay. And again, we know how to do this. We know 2 cubed is 8. We know 4 cubed is 64, and so on. Okay. But again, if we want to go backwards, we needed a new notation to take us from 8 back to 2. It's a similar idea up here, but obviously with a different power. So we introduced this idea, it's still a root, but we put this 3 in there, and that indicates the cube root of x. Okay. Most of the time you will not see the 2 written there. It's assumed when no number is written there, it's a square root. But if we want cube root, we do this. So again, if we want the cube root of 8, we have to come back here and think, what number cubed gives us 8? Well, that would be 2. And similar, the cube root of 64 is 4, because 4 cubed is 64. So again, the idea is we have this familiar function. When we wanted to go backwards or create an inverse function for it, we need a new notation. So we just created this symbol, and this will work for any of the powers. Right? We'll just do the corresponding root. Okay. So the similar idea is carried over here when we get to exponentials. Okay. So one of the first things we do in this chapter is talk about exponential functions. Again, not a big surprise, not a big challenge to us. So when I see something like 2 to the x, again, just to run through a few, all right, I know 2 cubed is 8. Okay. I know 2 to the 5th is 32. Okay. I know 2 to the 0 is 1. And I could go through a whole bunch of these. Okay. Well, now again, what if I want to go backwards? What if I want to say, how do I get 8 back to the 3? How do I know that 32 came from 2 to the 5th? Well, again, I need a symbol for it. Okay. Well, I can't use the root symbol. That means something else. So instead, we choose this notation, which is log base 2 of the number. Now again, you might not like this notation. This notation looks strange at first. It takes a lot of practice to kind of get used to it. Okay, but again, the idea is it's just the reverse of what we did over here. So this is the symbol, log base 2 of, I'll take my first example, 8. How do I figure that out? Well, again, you have to go back here. And you're saying, what is the log base 2 of 8? Well, since 2 cubed is 8, right, that's the base, is 2. So we're trying to figure out this exponent. 2 to what power gives me 8? 2 to the 3rd power. Okay, so it just helps us go backwards. Again, if I want log base 2 of 32, what you're trying to figure out is, well, 2 to what power gave me 32? Oh, 2 to the 5th gave me 32. So I know this answer would be 5. Okay. And similarly, if I want the log base 2 of 1, the question again is, 2 to what power gave me a 1? I know 2 to the 0 power gave me 1. Okay. But again, for right now, we're going to have to look back here every single time to try to figure out what some of these log values will be. Okay. And just like before, if we have a different base, we'll have a different log. Okay. So again, I'm just looking at f of x equal to 3 to the x. All right. Again, not difficult for us to understand. Well, 3 squared is 9. I know that. 3 to the 4th is 81. Let me take a negative. Remember 3 to the negative 1 means 1/3. Okay. If I could do any power of 3, then I want to be able to go backwards. Again, I need notation. So what's the reverse of taking base 3 to a power x? It's taking log base 3 of x. That's the notation that we use. Okay. So if I want to figure out what in the world is log base 3 of 9, what you're asking is 3 to what power is 9? 3 to the second power is 9. So the power would need to be 2. What would the log base 3 of 81 be? Again, this is asking the reverse. So 3 to what power gives me 81? Remember, this is log base 3. Here's the base you need. So 3 to what power gives you 81? 3 to the 4th. Okay. And then similarly, log base 3 of 1/3. What power of 3 gives me 1/3? 3 to the negative 1. Okay. So again, we have different bases that gives us different log functions. Okay. One more thing I'll just note here is we have two common ones. Square root is probably the most common root. For logs, the most common logs are base 10 and base e. So again, if I take base 10, right, I know things like 10 squared is 100, 10 cubed is 1,000, and so on. Okay. So the inverse, right, is the log base 10 function. Okay. Keep in mind that many times, this is called the common logarithm, that's the one that you're using when you don't write the base there. That's assumed to be base 10 if you don't have the base written. Okay, so again, log of 100, okay, which again means the same thing as log base 10. When no base is written, it's assumed to be base 10. 10 to what power gives me 100? 2. Okay. And log of 1,000, again, it's assumed to be base 10. 10 to what power? 10 cubed gives me 1,000. Okay, so again, the common logarithm is base 10 when it's not written. Okay. And then the other base we use fairly often here is base e. E is an irrational number that we'll run across in the chapter several times. E is about 2.7. Okay, and you'll see applications of it as we go forward. Okay, it's hard to actually calculate some values. You can do some decimal approximations. Okay, and you can put this in your calculator. The inverse, again, we almost never see this written, log base e. The notation we use is ln, which is just an abbreviation for the natural logarithm. Base e logarithm is the natural log, so we use the ln. Okay, so again, when we see this, we're thinking base e.